So when you are factoring out a greatest common factor, you're looking for the greatest common factor of the coefficients. 3 and 1 makes GCF of 1. And then you're looking for the greatest common factor of the variables. By nature, it just so happens that the GCF of a variable is the lowest degree. So in the first one, we have t to the 4th. In the second one, we have t to the 6th. The lowest is the 4, the lowest exponent, and so that means that I know I'm going to be able to factor out t to the 4th. So it does so happen to always work that it's just the lowest exponent of that letter. Okay? Now let's look at the second one there. The GCF of 12 and 3 would be 3, okay? And then we have x to the 5th and x to the 2nd, so I could divide out of there the lowest exponent of x squared. So that is the basic idea of applying what you know about GCFs to algebra. Okay? Now we're going to use that to factor out whenever we can. Bless you. We're going to factor out whenever we can. So I have 3 separate terms here, and I want to look at all 3 and find the GCF of those 3. So I have a 6, a 12, and a negative 36. The GCF of those would be 6, because all of those are divisible by 6. Okay? And then I have x to the 5th, x to the 3rd, and x to the 7th. So the lowest exponent is x to the 3rd. So what I want to do with that is I want to factor that out, which means I want to divide it out of my trinomial. If I take 6x to the 5th and divide it by x to the 3rd, I'm going to get x squared, because x to the 5th over x to the 3rd, our exponent rules keep the base, subtract the exponent, so that's x squared. So I'm going to be left with x squared for my first term. If I divide out the GCF of the second term there, 12 divided by 6 is 2, and the x third divided by x third is x to the 0, which is 1. So we say that those cancel. There's really a 1 there, but we do say that those cancel. And then we're going to take this last one and divide it by 6x to the 3rd. So we're going to get minus 6x to the 4th. And the 6 comes from negative 36 divided by 6. And x to the 7th and x to the 3rd, 7 minus 3 is 4. Now these are self-checking, and I wanted to point that out to you. You should never get these kinds of questions wrong, because all you have to do is go back to your answer and distribute that back out. Okay, so you triple distribute that, and you should get your original purple problem there when you do that. So these are all self-checking. All you have to do at the end is distribute it out and make sure you come back to your original equation. Okay, I want to talk a little bit about negative leading terms, because this is something that some of you have asked about and others I haven't heard you ask about at all, but it is something that happens once in a while. First of all, before we talk about negative leading terms, we want to make sure that our expression here is in standard form. So we want to rewrite it from highest to lowest degree or exponent. So we're going to rewrite this as negative 12 x to the 3rd plus 24x squared plus 15x. And now that I've got it in standard form, I want to talk with you a little bit about the negative leading coefficient. If you ever have a negative leading coefficient in quadratics, that is something we are going to want to avoid. We want to avoid a negative leading coefficient. So when you factor out a GCF of a negative leading coefficient, please make sure you pull out the negative when you do that. So I'm not just going to pull out 3x, I'm going to pull out negative 3x, because I want to get rid of that leading coefficient that is negative. So the GCF of those 3 terms is 3x, but since I have a negative leading coefficient, I want to pull out a negative 3x. And then I'm going to divide those all, each of those terms separately, by negative 3x. So I'm going to get 4x squared minus 8x minus 5. See that? All right. So how you know whether to pull out the negative or not is to take a look at your leading coefficient. If your leading coefficient is negative, please make sure you pull out the negative as well as the GCF. Okay? All right, factoring by grouping is next. Factoring by grouping, and then we'll pause for some questions, okay? Factoring by grouping. How you know you're going to need to do this. First of all, it will tell you, factor by grouping. Second of all, there's probably 4 terms, okay? So follow the directions, or if you see 4 terms like that, chances are you're going to factor by grouping, and try it, okay? And if it doesn't cooperate, then it maybe wasn't a factoring by grouping problem, okay? Notice that this one is not in standard form. That's okay. It works better when it's not. And I won't give you one that's all messed up. I will give you one like this that's ready to go, okay? So factoring by grouping, 4 terms, you're going to split them into 2. So we're going to have this binomial in the front, and we're going to pull out a GCF. Okay? Then we're going to have this one at the end, and we're going to pull out a GCF. Okay? So let's go ahead and do that. So the GCF of 10x to the third plus 4x is going to be 2x. So when we divide out a 2x, I'm going to get 5x squared plus 2. Am I right? Is that right? Okay. And then I've got my minus sign. And then with 25x squared minus 10, I'm going to pull out the GCF of, looks like, just 5. Yes? Okay. So we have a 5 we're going to pull out of there. And when I divide each of these by 5, I'm going to get 5x squared minus, let's see, is that right? Plus 2. Yep. Okay, right there like that. Okay, so notice that the items in the parentheses match, and that's what we want to have happen. Okay? These 2 things in the parentheses need to be matching. If they are not matching, then you have done it incorrectly, or you're not finished. One of those 2 things is happening. Okay? So now these match. I've got 5x squared plus 2 in both of the parentheses, and I'm going to write that as my first binomial. Hold on just a second. Let me finish, then we'll stop for questions, okay? And then the rest of my answer comes from 2x minus 5. So that's the second binomial right here, 2x minus 5. That is how you factor by grouping. I know that's hard to see. You'll be able to see it better on the computer when you get your copy, okay? Now there is a special case when we do factoring by grouping, and that is what happens if you go ahead and factor everything and your parentheses don't match where we want them to match. So let's keep in line with what you asked. We'll put the parenthesis before that subtraction sign right there. Does that help? Okay. And so we're going to factor this by grouping. So we're going to, out of the first one, we're going to pull out a 4y squared. And when you divide 4 by 4, you get 1, and y3 divided by y2 is y to the first. And then 4y squared divided by 4y squared is 1. So this is going to be y minus 1. Okay? And then out of the next one, I'm going to pull out, what would you like to pull out? 3 or negative 3. What shall we do? Negative 3. Okay, we'll pull out negative 3. And that's going to give me a 1 minus y. Is that correct?
No. Yeah.
Yes, negative 3 divided by negative 3 is 1, and 3y divided by negative 3 is negative 1y. Yes. Okay? But we said before our goal was to get these 2 to match, correct? But they don't match. But I did it right, but they don't match. But I did it right, but they don't match. Right? There's something you need to do to finish that problem out. And here's what you're going to do. You are going to take the second one, because it's kind of abnormal. 1 minus y is kind of weird, right? We like y minus 1. We're going to take that second one, and we're going to factor out, we're going to divide out another negative 1. Because we can. When we divide 1 by negative 1, we get a negative 1. When we divide minus 1y by negative 1, we get plus y. Are you okay with that? Okay. And I'm just going to bring the rest of this along. Okay. Now, we're going to take that negative 1 and we're going to multiply it by this negative 3 over here. So that minus 3 is going to change into a plus 3. So now I have 4y squared, y minus 1, plus 3. And before I write after that 3, let's see, can we rewrite it in the same order? Is negative 1 plus y the same as y minus 1? Yes, it is. So let's rewrite that how we like it. We're kind of picky about that. Okay. Now I can finish out that problem, and I'm going to run out of room here, so I'll go way up in the corner. We're going to write the first one as our parenthesis set, and then the next one is the remaining items, 4y squared plus 3. So that is a special case when you factor everything correctly down there to that red step and you go, uh-oh, it doesn't match, I need it to. And you can take care of that by pulling out a negative 1, having it join in with the minus 3 and turn it into a plus 3, and then finish factoring. Factoring by using guess and check. This is what I lovingly call unfoiling. So you have to be good at foiling before you can unfoil. You want to look at factors and sums of things. I'm not going to do all of those. This was just a selection of problems for me to choose from to work with you here. And also on the right-hand side, you can see that these things are self-checking as well. So you should not be missing any problems that you are asked to factor. You should be able to get those correct, okay? So the best way to talk about this is to go ahead and do a couple and just explain them as I go. Let's start with x squared plus 6x plus 5. We want to factor that into two binomials. So the first thing I always do is I just set up my parentheses, okay? The next thing I do is I look at my signs and see if everything's plus. And if everything's plus, I know that everything in my answer has to be plus. So I fill those in. All right? If everything is minus, then I'm going to have one of each sign. If I have a minus in the middle and a plus at the end, I'm going to have minus, minus. So there are some patterns there that happen. If you don't have those patterns memorized, that's okay. You can still figure these out. But there are some patterns, and the more you get to looking at the patterns, the easier it's going to be for you to factor. All right? So we're going to take this trinomial, we're going to factor it into two binomials, and we're going to use the guess and check method. Okay? Now we know that the first items of each binomial always give me my first term in my trinomial when I FOIL, correct? So what times what is going to give me x squared? X times x. So that part's easy. Now sometimes you'll have a number there. Maybe there's a 3, so this would be 3x and 1x or something like that. So the numbers are going to get trickier. Okay? And we know also that the last term of each binomial is going to give me my last item at the end. So what times what is 5? 5 times 1. Okay, it doesn't matter if you do 5 times 1 or 1 times 5. It doesn't matter which order those are in. They are the same answer because multiplication is commutative. So I'm going to go ahead and assume that I am correct. Now, of FOIL, what haven't I checked yet? The OI, the OI. Okay, so I can check that. Do my outside and my inside terms give me my OI in the middle that I am after right here? So on the outside I have 1x, on the inside I have 5x when I multiply, and 1x and 5x is going to give me my 6x that I'm after. So that does check. And that is how you can do the self-checking. Just take the binomials that you came up with and FOIL them back out and make sure that you end up with your original trinomial. So that's a very basic type of question, okay? Very basic, and that's guessing and checking. Sometimes you get it the first try. When the numbers get a little harder, it might take you 6 or 7 tries. So don't give up, okay? It might take you longer. There are some times when you get in the more complicated numbers and you try 6 or 7 different combinations and finally you get it. And there's other times you do a complicated one and you get it on the first try because you were lucky. Not because you were any smarter, because you were lucky, okay? And it's like, oh, it surprises you when you get it the first time. Oh, I got it. So be patient with these. Practice them enough that you can get good at them, okay? You want to make sure you can get good at them. All right, let's try another one. Let's do several just so you can hear me think about them. Let's go with number 14 here. X squared minus 4x minus 21. And if you want to get a little piece of scratch paper and try it, if you want to sit there and think about it for a minute. Okay, I'm going to factor this. First of all, I have all minus signs. And I know from experience that when I have all subtraction signs, I'm going to have one of each symbol in my answer. Let's focus on the first terms, x squared. So it has to be x and x. There are no other options. We can talk about 21. Okay? The factors of 21 are 1 times 21 and 3 times 7. Which of those factors would give me a combination when I added or subtracted them of 4? The 7 and the 3. So I'm going to put the 7 here and a 3 here. And I'm going to check my oi in the middle. This is minus 3x. This is plus 7x. That's a total of plus 4x. Uh-oh, I'm close, aren't I? So, what can I do to fix that? Change the 7 and the 3, just switch them around. So, let's do that. Let's just change the 7 and the 3. So, this is going to be minus 7 plus 3. Again, I can check that oi. I get an outside of negative 7x and inside of plus 3x. That's my negative 4x. Check. Is it helpful to hear how I think through those? Okay, so that's going to be just what you want to do as you're working. All right, let's do number 16 because it's a little bit more complicated. Not bad. 2x squared plus 9x plus 7. Factor it. Everything's plus, so I know I'm going to have a plus sign here and here. My first terms together multiplied need to give me 2x squared. So my only options are 2x times x. All right. Now I have to get a 7. My only options are 1 and 7. Do I want to do 1 and 7 or then 7 and then 1? What should I try first? Do I want to go 1, 7 or 7, 1? 7, 1, because I'm looking for a combination of my outside, inside of 9. And on the outside I got 2x, on the inside I got 7x. 9x is a sum of 2x and 7x correctly. Yes, there it is. Now if you had them the other way, you'd have gotten 15x, and that's not what you were after. So again, you need to check as you go. You can't just factor them and go, yeah, that works because 7 times 1 is 7 and 2x times x. You got to consider the OI in the middle. And that's how you can check really, really well. All right, let's go to maybe number 17. I'm going to end up doing almost all of them. 2x squared plus 9x minus 18. Factor, factor, factor. I have not all pluses. I have a mixture. I need a negative at the end, which means I'm going to need 1 plus and 1 minus. Okay, when you have a negative at the end, it's going to be 1 plus and 1 minus. We've got 2x squared at the front. That would split into 2x squared. You guys need to close your iPad, please. Times x. Okay. And then I need to get an 18, so I could do 1 times 18, 2 times 9, or 3 times 6. My goal is to get a 9 out of my OI, a positive 9. 6, 3. Okay, we could try 6, 3. That's going to give me an outside of negative 6x and an inside of positive 6x. Uh-oh, they would cancel. So nope. Not 6, 3. What'd you like to try next? 3, 6. Okay, let's try 3, 6. 3, 6, this is going to be negative 12x and a 3x, and a negative 12x is a negative 9x. I'm close. Switch the signs. Okay. See, it took us 3 tries, didn't it? So switch the signs. Make that one a minus. Make this one a plus. Now I have 12x. And a minus 3x, and there's my positive 9x that I'm after. There it is right there. We're going to look at 19, 20, and 21. We want to know if a given trinomial is considered to be a perfect square or not? Which means when you FOIL it, do you get the same thing in both parentheses? Okay? So if you are asked, is this a perfect square trinomial, what you want to do is factor it and see if you get the same thing in both sections. So we'll just look at number 19. We've got a squared plus 14a plus 49. And everything's plus. And when I factor a squared, I'm going to get a times a. And when I factor 49, I'm going to get 7 times 7. And then I want to check my OI. 7a and 7a is 14a, which is what I want in the middle. So that checks. I got both parts to match, so I'm going to say, yes, this is a perfect square trinomial. And that's all you have to do. By the way, this is oftentimes rewritten as a plus 7 to the second power. That's a plus 7 times itself. So very often you will see that written squared. When you do see it like that, feel free to write it out the long way if you need to FOIL it. Okay? That's all on that page I wanted to talk about. And then on the next page, I want to talk about if a binomial is a difference of two squares. So the word difference, you need to see a subtraction sign. The phrase two squares means that both of your terms are perfect squares. So let's look at number 22. B squared minus 16. First of all, is that a difference? Yes, it is. Second of all, is b squared a perfect square? Yes, it is. Is just 16 a perfect square? Yes, it is. Then 22, b squared minus 16, is a difference of two squares. Now we know from shortcuts in multiplying binomials that when you have a difference of two squares, your answer is going to look like this, correct? They're going to match, but one's going to be a plus and one's going to be a minus. So those of you who were good at catching that shortcut when we FOILed with the plus and the minus, this is just doing that in reverse, okay? What happens to the OI? It disappears. It cancels itself out. All right, let's look at number 23. 25y squared minus 10. First of all, is it a difference? Yes. Is 25y squared a perfect square? Yes, I could square root that and get 5y times 5y. What about 10? No. So that is not a difference of two squares. You can factor it. You just can't factor it into two binomials. You could pull out a 5 and get 2y squared minus 2. 5y squared minus 2. There we go. 5y squared minus 2. So you could still factor out a GCF, but you just can't factor it into two binomials. All right? And then let's move on to the next one. Number 26, 27, 28. Are those items completely factored or not? So this is something that's good for you to see because a lot of times I look at your answers, and this is why I put this in here. I would go around and look at your answer and go, oh, you didn't factor that all the way. There's one more thing you can pull out of there. Okay, so let's look at that. 6x minus 3 times x plus 5. What can you still factor out?
3 in the first part.
Yeah, you can, in the first binomial, 6x minus 3, isn't there still a GCF of 3? Okay, so that is not factored completely yet. And what you want to do is you want to pull out the 3 and rewrite the problem with the 3 outside and factored out or divided out of that first binomial. Okay? So be on the lookout for that. A lot of times students will give me a paper or a quiz or something. They'll hand it to me and I'll say, oh, that one's not finished yet. What? What do you mean it's not done? I factored it. Well, there's still a GCF there. So always be on the lookout to make sure that your final answer has no other GCF in it that you could pull out. Next, factoring each polynomial completely. Okay? Factoring each polynomial completely. How do you know if something is completely factored? Okay? The first thing you're going to do is you're going to check to see if you can pull out a GCF. So let's look at number 33. 100x squared minus 80x plus 16. 80x, there we go. Anything else I missed? 100x squared minus 80x plus 16. All right, so what's the GCF of 108 and 16? More than 2? 4. Okay, so we're going to pull a 4 out of that. 4, then I'm going to get 25x squared minus 20x plus 4. Now, I'm not finished. I haven't factored it completely because guess what I can do with that trinomial? Split it into 2 binomials like that. Okay? So the first one, what's the first thing we're probably going to try since it's 25? 5x and 5x, yeah. I have a plus at the end, but a minus in the middle. That means these are both going to be minuses because I need the ends to be positive 4, but I need my middle to be negative sums. Okay? So 4, how should we split 4? 4 and 1 or 2 and 2? What should we try first? 4 and 1. Okay, 4 and 1. That's going to give me on the outside negative 5, on the inside negative 20. That's going to give me negative 25x. Nope, not quite.
2 and 2.
Let's try 2 and 2. Yep. 2 and 2. On the outside, that's negative 10x. On the inside, that's negative 10x. Negative 10x and negative 10x is negative 20x, which is what I wanted right here. Right there. Okay, now that is factored completely. Whoops, trying to erase. There we go. Factor completely. You may see that rewritten with an exponent of 2 after your binomial. See that? Okay. Well, you could have, but what you would have ended up with later on, you may have ended up having to pull out a GCF of 2 out of each of your remaining binomials. Okay? You would have had 10x minus 4. Those aren't factored completely. The 10 and the 4 are still factorable. So then you would have had to pull out a 2 out of each of those. There's your 4. All right, let's look at number 34. And the reason I want to look at number 34 is because this is a tricky one that I see once in a while on tests, and I don't want you to be stuck by it. So number 34 is 7m to the 8th power minus 7. So let's start by pulling out a GCF. 7, okay? 7 parenthesis m to the 8th minus 1 close parenthesis. How many of you think I'm done? And nobody's going to raise their hand because you know I wouldn't say it unless I wasn't done. You know me well, okay? I need to split m to the 8th minus 1 into 2 binomials. There is no center term. What does that tell me about my signs? They're going to cancel. So in my binomials, I'm going to have 1 plus and 1 minus, and my parentheses are going to match other than that, correct? Okay, so how do I get m to the 8th? Square root that. M to the 4th times m to the 4th. Good. Because 4 plus 4 is 8. How about 1 times 1? Is 1. All right. Do you see how many students might think that that middle row is finished? But it's not. Okay? Whenever you see a perfect square minus 1, you've got to go one more step. Okay? That's the difference between my A plus kiddos and my A kiddos. The A plus kiddos catch that minus 1 and they continue on. Okay? So keep that in mind as you're working. All right, 3 things you want to always be sure and do. Always factor out a GCF first if you can. That's what we just practiced with the last 2 examples. Okay? Next, always factor out a negative 1 if the leading coefficient is negative. Okay? Always make sure you factor out your negative. And then thirdly, always make sure that you are self-checking these. Everything that we did can be FOILed back out or multiplied back out to get you back to your original equation. And if you're not getting back to your original equation, then you don't have it just yet, okay? All right.